It says you must understand why sometimes ratios are negative and sometimes positive. Answer the following questions to see what the pattern is. So draw the related acute angle 20 degrees beside x-axis in each quadrant and state the principal angles each forms with the initial arm. So what that means is, if for example, I start by drawing this angle as 20 degrees, well, this part, I'm also going to draw it as 20 degrees, 20 degrees, 20 degrees. So those are all 20 degrees. Meanwhile, the corresponding angles will be 20 degrees. The angle over here is going to be 160 degrees, 200 degrees, and then 340 degrees. And that's because you have 0 degrees to 360 degrees over here, 90 degrees, 180 degrees, 270 degrees over here. Meanwhile, it is helpful for us to write, this is quadrant 1, this is quadrant 2, quadrant 3, quadrant 4, and let's go from here. So basically, I need to calculate the sine, cosine, tan for these degrees, these principal angles. And so, for example, I'll start off with quadrant 2, because I usually write left to right. So sine 160 degrees, if I put that in the calculator, I get 0.3420. And if, let's say, I'm doing it in a way that I'm doing all the sines at once, if I do sine of 200 degrees, I get negative 0.3420. Notice that the values are the same, but one of them's positive, one of them's negative. Moving on to this quadrant, if I do sine of 20 degrees, I get 0.3420 on the calculator. Sine of 340 degrees is equal to negative 0.3420. So just look by looking at the sine of 160, 200, sine 20, sine 340, which all correspond to the same related acute angle of 20 degrees, but is at different quadrants. I'm getting the same values but different signs. So I'm going to quickly go through that with the cosine and tan. So cosine 160 is negative 0.9397. Cos of 200 degrees is negative 0.9397. Cos 20 is equal to 0.9397. Cos 340 is equal to 0.9397. So notice that the values are the same again. Some are positive, some are negative, and we're trying to figure out a pattern. Going on to tan of 160 degrees. I'm getting negative 0.3640. Tan of 160 degrees is 0.3640. Tan of 20 degrees, 0.3640. Tan of 340 degrees is equal to negative 0.3640. So again, for all sine, cosine, tan, I'm getting the exact same values, but different signs. Okay, so I'm going to write that down by writing. So for the same related acute angle, all sine ratios are the same magnitude, meaning the same value, but different sign, also the same thing for cosine and also for tangent. So see how it's 0.3420, negative 0.3420, 0.3420, and negative 0.3420. Okay, so that's part C of what we notice. What's another thing that we notice? Well, let's take a look at sine, cosine, tan. Okay, so which part is positive? Well, the primary trig ratio for sine. So only sine is positive. Okay, next, that was for quadrant 2. And then what about for quadrant 3? Only tan is positive. Okay, on to quadrant 1. Well, look, all three trig ratios are positive. Cos is only cosine is positive. So I know this whole thing looks very complicated and looks really fancy, but what we notice is that it doesn't matter basically from part C, what we found was it doesn't matter what related acute angle you're working with, you're getting the same values. And it depends on the quadrant you're in, they're telling you whether it's positive or negative. So we need to delve deeper on why this is occurring. But meanwhile, we notice that for the signs like plus and minus, it is dependent on which part we're looking at. So for example, so you're telling me based on like my highlights that I have S that is always positive, or that is positive for quadrant 2. We have T, tangent, that is positive for this made example for quadrant 3. And for for quadrant 1, all of them are all positive. And then while for cosine, cosine is positive for quadrant 4. So keep in mind with the 20 degrees, that was a random selection of an angle. And so this is called a cast rule because it doesn't matter what angle you're referring to, but cosine will always be positive in this quadrant 4. Quadrant 1, well, all the values will be positive in this quadrant. Well, it has to do with the fact that x is all positive here and y is all positive here. Remember how we talked about that from here? Okay, we're gonna like try to make sense of all this. And then the S um is positive for quadrant 2, and then for T, quadrant tangent is positive in quadrant 3. And so cast rule tells you basically where sine, tangent, and cosine is positive, meanwhile all trig ratios are positive here. So we have the cast. Okay, so cosine is positive in quadrant 4. Just keep in mind though, although quadrants go 1, 2, 3, 4, cast goes C-A-S-T. So it doesn't like work perfectly. Okay, so just keep that in mind. The quadrant and the cast flows differently. Okay, so this is cast and this is the quadrants. All are positive in quadrant 1. Sine is positive in quadrant 2. Tan is positive in quadrant 3. And there you have the cast rule. Let's try to look at question 4 for a second. The acronym CAST is not always useful. Angles can fall onto the X or Y axis. Answer the following questions to really understand the new definitions of sine, cosine, and tangent. So basically, CAST is all great if all the angles fall in between. And so we're considering when we have the coordinates fall right on the axis and trying to interpret that case. We have here 1, 0. And so if you were to take sine of 0 degrees and put that in the calculator, you'll get 0. Cos of 0 degrees, you get 1. Tan of 0 degrees, you get 0. And simply just putting in your calculator, okay? All right, we're going to go back to all these numbers. Now go to the second coordinate, going counterclockwise. We have 0, 1. So sine of 90 degrees, because we're at the 90 degrees point, 90 degrees is equal to 1. Cos of 90 degrees is equal to 0. Tan of 90 degrees, if you calculate that, you will get undefined, or NA. Let's go to the third coordinate, negative 1, 0. So sine of 180 degrees is equal to 0. Cos of 180 degrees is equal to negative 1. Tan of 180 degrees is equal to 0. Next, 0, negative 1. Sine of 270 degrees is equal to 1. Cos of 270 degrees is equal to 0. Tan of 270 degrees is equal to undefined. Okay, meanwhile, keep in mind that we would have been dealing with these kind of line segments that lead to our coordinate. to help you visualize it even more, highlighter, I'm going to do one thing. So I see a 1, then a 1 here. I see a 0 here, and I see a 0 here. I see a -1, and I see a -1 here. See a 0 here. See a 0 here. So what do you notice? What do you notice for cosine? Okay, if it's not that obvious yet, let's go on to the second part. I'm going to circle 0 here. Also notice there's a 0 there. Notice that this is a 1, and this is a 1 here. See a 0 there, and a 0 there. A -1 there, -1 here. Okay, so do you notice anything? Do you notice the connection between sine and one part of the coordinate and cos and one part of the coordinate? So what you should be noticing is that for cosine, let's say, okay, that is my pink part. The sine is the y-coordinate on the unit circle given that the radius is equal to 1. Meanwhile, for cosine, you could probably now see the connection that it is the x-coordinate on the unit circle when radius is equal to 1. So taking a back step for a second, so basically when you take sine of 0 degrees and you make it, and that equals to 0, that 0 is actually referring to the y-coordinate of that coordinate. 0 and you get 1, it was referring to the original x value of that coordinate. And then we have to try to interpret the tan. So remember my hint with how I drew these lines. Do you see any resemblance between how the lines worked out and what you got for tan? So for this horizontal line, I have a tan value of 0. For this vertical line, I got a value of undefined. Horizontal line, 0. Vertical line, undefined. What do you think? So basically, tangent is the slope of the terminal arm. So if you have moved over right 1 and you didn't go up or down at all, that means you have a horizontal line. And if you were to try drawing this like invisible triangle, you can't, just like a line segment, and therefore the slope is 0. Tangent is referring to the slope based on the x and y. And in this case, we have a unit circle, and that's why it's fixed at these values. Okay, so let's try to interpret it one more step. What are the new definitions of sine, cosine, and tangent? Keep in mind the circle doesn't have to have a radius of 1. Also, what does the Pythagorean theorem remind you of? So if I was you, I would probably be confused because there's a lot going on right now and we're doing this all digitally. So I'm hoping that this part helps make it a little sense. Okay, so in the previous case, we had this unit circle. It was located at 0, 0, and the unit circle is special so because it gives us a lot of information, such trig ratios like sine 0, cos 0. But we want to be able to do it beyond the unit circle, and this is what it looks like. So it's like if I have this circle and I wanted to find out an angle respective to this circle, meaning if I drew a triangle within this circle, it will look like so. And so think it through. Basically, from here to here, that is my x value, right? From here to here, that is my y value. Following, okay? And then as a result, there's like a connection between a circle and a triangle because, well, what would this be? Well, if this is the right angle triangle and this is my circle, that would be my radius. Wasn't sure what the theta was, what that angle was over there. If I have the coordinate, then I can maybe find out my theta, and that's where everything's coming together. Like, what is your missing piece? Is it the angle? Is it the r? Is it the y? Is it the x? And this is how everything's coming in. And so, for example, if this is my angle of reference. That means this is my adjacent, this is my opposite, this is my hypotenuse. And so to this picture, what I'm doing is applying SOHCAHTOA. So how does that work? Okay, so let's write things that we know. So we have sine theta, and that is equal to opposite over hypotenuse. Cos theta, which is equal to adjacent over hypotenuse. We have tan theta, which is equal to opposite over adjacent. And then let's interpret our triangle. So with our triangle, that means that, well, for my sine theta, my opposite is my y, and my radius is r. So how come sine was equal to the y? Well, in our case over here, our radius is equal to 1 when we go back to the unit circle. And that's why sine theta was magically equal to the y of the coordinate, right? But meanwhile, if it's not a unit circle and I'm not dealing with a radius of 1, but I'm dealing with radius of 2, radius of 5, this is the general equation for it based on my triangle that I've just drawn. Okay, so now let's keep going. With cos theta, it's adjacent over hypotenuse. Adjacent is x over radius. Cos theta is equal to x. And cos theta would equal to x exactly if radius is equal to 1. Back to that unit circle, right? Cosine is the x coordinate on the unit circle. But as soon as your radius value is something else, then we're just going to use cos theta is equal to x over r. Next, opposite over adjacent for tan theta. So opposite is y, adjacent is x, y over x. Well, what does that mean? Well, when you try to find the slope, you're doing rise over run, and that is slope, and that's why I was referring to this. And when I was referring to tan, I was I was getting you to focus on looking at these as the lines. Like this is the horizontal line, this is the vertical line. I was thinking, trying to get you to see that slope. And so for the tan theta is related to the slope. And so I put a box around this because I feel like this part and this part are parts of this lesson. You got to know or memorize, because if you know this, you don't have to remember this. If you're able to draw this out, you could get this. Okay, so I say know or memorize. I prefer the knowing. If you're able to draw this, you'll get this. If you're able to get this, you can technically get this. I mean, with practice, right? But these two are the important parts. Okay, on to the next page. So you might be like, we could just use a calculator for this unit. Great, just like we've been doing in the previous pages. But as you can see over here, you're not always going to use a calculator. You have to go through it the exact way, and that's why it's important that you're able to show both the exact way and the approximate way. So a lot of trick, there is the exact way. So the whole was kind of warming us up to the exact versions. So question 5 says you cannot rely on the calculator to give you the answers that you need anymore. To see this, answer the following question. But again, don't be scared. It takes practice, but it's nothing to be scared of, hopefully. Okay, so basically you have this principal angle. This is represented by the theta sign. This is the alpha sign, which is showing me, what do you think this is? This is the related acute triangle. And so they have given me a single coordinate. So let's try to break this down. For the point P, -3, -5, find the following ratios. Okay, so before I do that, I'm going to break this question apart. So step 1, I'm going to work with a diagram. Okay, next, I want to break it down because if you notice, I basically have the x of the coordinate and I have the y, but I don't know the r. I have no idea what the radius of this triangle is, or meaning the hypotenuse of this triangle. And to picture you what I'm talking about, if this is the x and x is equal to -3, because you went left 3, and y is equal to 5, or more exact, -5 because you went down 5. We don't know what the radius is, and radius will always be a positive number because radius of a circle is always a positive number, and you're basically adding the sums of two squares and square rooting it to get the radius. So you'll always get a positive for the radius. So Pythagorean theorem. X squared, well, y squared equals r squared. That could be our version for our right angled triangle moving forward. I'm going to plug in -3 for x and -5 for y, and we get r squared. Therefore, I get 9 plus 25 is equal to r squared. So I have 34 is equal to r squared. And so how do I get r by itself? Well, I'll get positive and negative versions, but I only need to grab the positive, and therefore r is equal to positive square 34. It's a radius, so I need to write down it's in units. All right, now that I have my rough work planned out, now I can start writing down my sine theta. So remember from my box from before, sine theta is equal to y over r. So I'm going to write down all those down. So sine theta is equal to y over r, equal to x over r. Tan theta is equal to y over x. And so I'm going to start plugging in at this point. So y is equal to -5. My radius is equal to square root of 34. I'm going to plug in everything. X is -3 divided by square root 34. Tan theta is -5 divided by -3. Well, tan theta looks pretty simple. I just need to divide the 2, and I'll leave it as a fraction, and it's 5 over 3. I don't want any negatives in the denominator. At this point, so recall from the previous units on how to rationalize a monomial. To get rid of that square root of 34, I'm going to multiply the top and bottom by square root of 34. When you do that, you are doing 34 times 34, and you're going to square root that. So you're going to get 34 right back. Same thing here. That's the denominator. And then on the top, I have -5 times square root 34, -3 square root 34, and that's it. So that is my sine theta, cos theta, tan theta. And I know it's bad format to write it across. Right now we don't have room, but these are kind of our corresponding answers. Let's move on to B. Now use the inverse buttons for each ratio to find the angle. So basically what you're doing is, you're kind of following the highlights, and you're getting theta is equal to sine inverse of, just copying that highlight down, 34 over 34. So -5 square root 34 over 34. And that is equal to, bad format again, -59 degrees, if you put that in the calculator. So let me just put everything down. So cos inverse of -3 square root of 34 over 34. Theta is equal to tan inverse of 5 over 3. So maybe I should talk about why this is working, why this is okay. So in the previous question, all we found were the trig ratios, the primary trig ratios, right? And so sine theta is equal to this, cos theta is equal to this, tan theta is equal to this. They never told me in question A to solve for the angle, but keep in mind you can solve for these thetas easily by just trying to get that theta by itself, and the operation to getting that theta by itself is to do sine inverse of both sides to get the theta by itself. And that's what I'm doing in part B because they told me I need to find angle theta. And if I was to keep going, I'm going to get angle 121, angle about 59 degrees. I'm going to draw these out quickly so you know where about they are. This is how I do it. If this is 0 degrees, that means it went from here, the initial arm, and it went down -59, which means I went clockwise for that to happen. So that is -59 degrees. We are consequently in quadrant 4, by the way. Okay, keep going. I have angle 121, so I know that's 0 degrees, that's 90, and so it's not yet at 180, so I know it's in this quadrant. And it's really important that you practice and you get good at drawing these out. And when you're all stuck, just make sure you write those 90, 180s out so that you don't make a mistake on this, because you can most definitely get it right. So 0 to 90 degrees, that means the third angle is at 59 degrees. And it's a sketch, so it doesn't have to be perfect. As long as it's in the right quadrant, that would be the main focus. We have quadrant 4 for the first one, quadrant 2 for the second one, and quadrant 1 for the third one. This is kind of what it means. We can use the primary trig ratios to find out more information, and we found the respective angles to these trigonometric ratios. But we saw in this example that there's just a lot of ways you can represent sine, cosine, tan, and it really depended on the quadrant. The quadrants really mattered. Right at this point, I want my angle to actually be in quadrant 3. What I'm going to write down is this, FYI. So find the acute related angle and check your angle is in the correct quadrant. Okay, so what I mean is if you look at this, what is the related acute angle that's screaming at you that wasn't that noticeable from the beginning? From here to here, I didn't notice, but then as soon as I got here, I keep noticing something. What angle? The 59 degrees. That is the related acute angle that keeps popping up. Well, it's in the wrong quadrant, but the related acute angle that they're giving away is 59 degrees. Over here, if I did 180 minus 121, that's 59 degrees, and 59 degrees again. So these parts were helpful in telling me what the related acute angles are. Didn't tell me the exact answer I needed, but got me really close. And so I'm going to write all answers are different, but if you find the related acute angle, 59, you could work from that information. So what I mean is this. So I'm going to draw the x and y axis, and I'm going to draw my principal angle, which is going to be somewhere over there. And we know that the related acute angle is supposed to be 59 degrees with respect to the x-axis. And if that is the case, and we have 0 degrees, 90, 180, 270 degrees like that. Well, what is this going to be? Well, think of it this way. From here to here, if from the initial position to this part is 180 degrees, I could add 59 degrees to get this principal angle. And that's exactly what I'm going to do. I'm going to say theta is equal to 180 plus 59 degrees is equal to 239 degrees. Question D, it says, what must be done when you use inverse buttons when dealing with obtuse or reflex angles? You need to draw a picture and use symmetry in the related acute angle and make sure it's always positive. Working with this reflex angle, I broke it down so that I could see the related acute, well, in this case it was given. You're focusing on the related acute angle, breaking down all the information, and making sure that you're finding the proper principal angle. And so you're not working purely from this reflex angle, which just means an angle larger than 180 but less than 360, but you're working with that related acute angle. So you need to draw a picture and use symmetry and the related acute angle and make sure it's always positive. Related acute angle is always positive. Notice I didn't take the negative 59, but I took it as a 59 degrees. 6. For the angled negative 170 degrees, it says find the related acute or the reference angle. So right away, the x and y axis from the initial arm, which is over here, and you're going to draw so that you get to negative 170. I always draw my like terminal arm, and from there to there, that's negative 170 degrees. They're asking me for the related acute angle, which is going to be 10 degrees. And how did I know that? Well, from here to here would be negative 180 degrees. And so this must be 10 degrees. Therefore, related acute angle is equal to Part B, I am going to erase the part, which is this, and keep going from there. I'm going to go from the fact that you don't know CAS rule and just interpreting this question that way. So it says, predict the signs of all the primary trig ratios, explain your choice using the new definitions of the trig ratios. So if you have sine negative 170 degrees, that's finding one of the three primary trig ratios, right? Cos negative 170 degrees and tan of negative 170 degrees is what they want you to find out. We found from the definition, new definition of the trig ratios, that this is actually equal to y over r, x over r, and y over x. You should know that radius is always positive. Let's take a look at that coordinate. So doing like a really rough x and y. Well, my x value will be a negative there, and my y value will also be a negative there. So do you see that? If it was like a -1 and a -1, -5, comma -5, it doesn't really matter what that value is because we're dealing with just a sign. Like, what is a sign going to be? And so I have, well, my y is negative, and my radius has to be positive. And if you have a negative divided by a positive, you have negative. On to the next one. I have an x that is a negative, and r that is positive, and negative divided by a positive is a negative. And y over x, well, I have a negative divided by a negative, and that is overall a positive, because when you divide or multiply two negatives, you get a positive answer. For the sign, remember, since sine is y, and we notice that the coordinate is below the x-axis. My y is supposed to be negative, and so everything kind of lines up. Okay. My cosine. Well, since sine is x, and it's left of the origin, that being negative also makes sense. Lastly, for tan, well, take a look at this line segment as a slope. From left to right, you are going up. If you're going up, that is a positive slope. And therefore, since the terminal arm has a positive slope. Okay, and without knowing the CAS rule, that's what you could have done. With knowing CAS rule, that's C, that's A, that's S, that's T. Well, my sine will be negative because only my tangent is positive here. So my sine is negative. That's based on CAS rule. And for cosine is negative because tangent is the only one that is positive. And then for tangent is positive. So that's how you read the CAS rule. 7. We have negative 140 degrees, and we started off from 0 to negative 180 degrees if we're interpreting it from clockwise. That makes my related acute angle equal to, well, 180 minus 140 is 40. And remember, you always want to be writing your related acute angle as a positive. I'm going to write related acute angle is equal to 40 degrees. The diagram. Next, I have my principal angle. Well, what is my principal angle? Well, if my related acute angle is 40 degrees, that means, well, from here to here, that's the 90. From there to there is 180. And then 180 plus 40 is equal to 220. Another way you could have done it is you could have said 360 minus 140 right away. Many ways as long as you're getting 220 as your principal angle. C, find a few equivalent expressions to tan negative 140. Let me bring up the cast rule. So you have your cast right here, and this is how you interpret it. This is where tan is positive for now. So if I have tan negative 140, which happens to be about 0.8391, and I'll just put that on the bottom. I need to come up with equivalent ratios to that, meaning if I was to put basically coterminal angles with this, correctly get some of these equivalent ratios. So given that this is quadrant 3, this is quadrant 4, I basically wanted to lie on, let's say, quadrant 1 or quadrant 3 if I don't want to make any changes to my other ratio. Meaning, if I have tan negative 140 and my related acute angle is 40 degrees, that means if I drew another angle here and had a related acute of 40, that's going to be an equivalent ratio. So I'm going to write tan 40 degrees, which FYI is in quadrant 1. So I picked tan 40 as my first choice because they're both going to be positive here, and so that's going to be my easiest choice. Next, what should I do? I had tan of negative 40 degrees. That is this angle right here. So it would have a related acute angle of the 40 degrees, which is fine. But these are negative over here. My tan ratios are negative over here. And all I have to do in that case is write a negative in front. And then we're happy because then the signs are fine. You just have to write an equivalent ratio, and so you just write a negative in front of the whole thing, and that is okay. And so you write, and that is in quadrant 4. Tan negative 40.
So since tan negative 40 is negative, I need to put a negative sign in front of that tan negative 40 so that tan negative 140 is going to equal to the negative version of tan negative 40 degrees. So it'd be a good practice to use a calculator and check that these values are lining up okay.
So what you should be getting is that tan 40 is equal to 0.8391, and negative tan bracket negative 40 degrees is also going to equal to 0.8391 because we forced that negative in front of it. Tan of, well, that's around 90, 180, 270, it's getting to 360. Let's say we had tan of 320, which is that same angle as tan negative 40, but I'm just writing it in the proper form. So if I have tan of 320 degrees, see how I'm in quadrant 4 as well? What do you think I need to do? I need to put a negative in front of that, just with the same reason as the one above. Over here, so if this had a related acute of 40, I get 140 because 180 minus 40 is 140. So tan of 140, quadrant 2. And I have to also put a negative in front of that because it's not in the quadrant where they're positive or the same sign as the one I want to. So tan, next time let's try tan 220. So I would have gotten that by doing 180 plus 40. So as long as you're working with that related acute angle and it's with respect to the x-axis. Well, that's in quadrant 3, so I don't have to change the sign. And finally, tan, if I have 400, well, that is beyond 360, and that just means now I'm back here. And that means I'm in quadrant 1. Help you distinguish that these are all kind of the ones that had the opposite signs, and therefore I had to put a negative in front of those. Whereas the blue ones, I didn't have to because it belonged to the ones where They were the same sign as the one I wanted, and so we were good. And so these are some ways that you can write a few equivalent expressions to tan negative 140 degrees.